Okay, good afternoon dear students. So today we will solve a example related to the algebra of continuous function. In this question the function is fx equal to this and verify the continuity of this function at x equal to 0. For x equal to 0, the left hand limit of this function is limit x tends to 0 negative, and the value of this function fx, when we take x tends to 0 negative, then the value of the function is this. It is equal to limit x tends to 0 negative, the value of the function is 2x minus greater integer function and sine 1 upon x. Okay, in this case we have three function. This is first function, this is second, and this is third function, and we know that about the greater integer function. This is the graph of greater integer function. Okay, and this is minus 1, 1 and 2. For at x equal to 0, this function is at x equal to 0, the limit of this function is 0. At x equal to 0, this is a finite value because sine 1 upon x, when we put x equal to 0, then sine infinity, and sine infinite equal to some finite value. Because the graph of the sine x is this. So this function has some finite value. This is the value of this at x equal to 0 negative is 0. So it is equal to 0, and when x tends to 0 negative, it means there is something less than 0. Then the value of this is minus 1. This is minus 1, and okay, 0. This is minus of minus 1, and this is some finite value. Then it is equal to 1 plus some finite value. Okay, and this is the left hand limit of this function. And similarly, the right hand limit of this function is limit x tends to 0 positive f of x, and similarly the for right hand limit, this is the function. Then it is equal to limit x tends to 0 positive, and the value of this function is 2x minus of greater integer function sine 1 upon x. Okay, and it is equal to limit x tends to 0 positive. This value is at x tends to 0 positive, this is 0. This value is at when x is greater than 0, when x tends to 0 positive, then the value of this function is 0. This is also 0, and this is some finite value. Okay, then it is equal to finite value, some finite value of sine x, and the value of the function at x equal to 0 is 0. It means the left hand limit not equal to right hand limit, not equal to the value of the function. The function is discontinuous at x equal to 0. Okay, and we can simply calculate the discontinuity of this function, because this is continuous everywhere in the real line. This is continuous, and this is discontinuous at every integer point. So this function is discontinuous according to the algebra of continuous function. Okay, this is the question of algebra of continuous function, and in next lecture we will solve another question. Thank you.